This is Mission Control Houston, where we are live preparing for the arrival of the Northrop Grumman CRS-19 cargo resupply mission to the International Space Station. In about an hour and a half from now, NASA astronauts Woody Hoburg and Frank Rubio, who are currently on board the International Space Station, will be using the station's robotic arm to capture the Cygnus cargo spacecraft. Capture is currently scheduled for 5:55 a.m. Eastern Time, 4:55 a.m. Central Time. We are providing live coverage of Cygnus's approach, capture, and final berthing to the International Space Station. Thank you for joining us. This is Mission Control Houston. Northrop Grumman's CRS-19 cargo resupply spacecraft on its way to the International Space Station. It launched Tuesday evening at 8:31 p.m. Eastern Time from NASA's Wallops Flight Facility on the eastern shore of Virginia. Teams had a tally-ho with the vehicle just after 3 a.m. Eastern Time, and it conducted its approach initiation burn about 15 minutes ago.
Lift off the Antares NG-19 launch tube, all facility.
Over 8,200 pounds of important experiments, hardware, and supplies are being delivered to the crew that is living and working in space right now. We are currently in a handover period of our video, but we should get live views of the Cygnus spacecraft here in a couple of minutes.
Stage 1 TVC is normal.
Attitude nominal.
Vehicle attitude remains nominal. Power nominal.
Vehicle passing through max Q.
Vehicle now passing through max Q. Core pressurization remains nominal.
You are looking at live views now of the Cygnus cargo spacecraft approaching the International Space Station, under 400 meters now. The vehicle's most recent burn, a ADV burn, approached delta velocity. This was the fourth burn. It is going to have Cygnus rendezvous up to a 250-meter hold position that is just outside the keep-out sphere. Right now, the vehicle is inside the approach ellipsoid. There are two invisible lines around the International Space Station. You can see in this graphic here the approach ellipsoid and the keep-out sphere. That approach ellipsoid denotes joint operations because of station safety. Once the vehicle gets into that keep-out sphere, it is monitored even closer by flight controllers. It also gives the crew on orbit command capabilities as it is so close to the station. As of now, Cygnus is inside that approach ellipsoid on its way to the keep-out sphere. For arrival today, on board we have NASA astronauts Woody Hoberg and Frank Rubio. They are on tap to capture the Cygnus spacecraft. They're going to be using the station's robotic arm. At the end of the arm are snares and a lee. Lee stands for the latching end effector. It's the hand of the arm. Inside are those latches and snares that will grab on to the grapple target of the spacecraft. They will then be maneuvering it to the nadir or Earth-facing port of the Unity module. And after that, they will hand it over to our robotic operator here in Mission Control Houston to install it to the space station. This is a cargo resupply mission. There are no crew currently on board the spacecraft. It is delivering over 8,200 pounds of supplies, experiments, and hardware to the crew. Here we have a breakdown of that weight. This is Northrop Grumman's 8th contracted resupply mission for NASA under the Commercial Resupply Service CRS-2 contract. It's their 19th total resupply mission to the International Space Station. Flight control team members here in Mission Control Houston are preparing to do a go-no-go once they reach that 250-meter hold point. Right now, Cygnus is reaching 300 meters from the space station. Here in Mission Control Houston, a couple of very important console positions playing a role in Cygnus's arrival today. We have our flight director, Fiona Turret. She is NASA's 100th flight director, part of the class of 2021. Her call sign is Mosaic. Working at NASA was always the goal for her through high school. She went on to achieve a bachelor's degree in mechanical engineering from Washington University in St. Louis and came to work for NASA. She supported the final 2 years of the Space Shuttle program and also worked on the Gateway Lunar Outpost and the Human Landing System, that's the Moon Lander programs, prior to being selected as a flight director. Sitting next to her is, in the background there, is our Capcom. That's our capsule communicator position. That's Megan Harvey. She is going to be our voice link today between the crew and the flight control team. Our visiting vehicle officer today is Nick Lopez. He is communicating between Northrop Grumman and the flight control team, keeping track of Cygnus's performance and milestones. We also have our integration systems engineer, Lisa Malam. She is responsible for monitoring key systems and operations of the Northrop Grumman vehicle for NASA. Looking ahead on our milestones today, the Cygnus spacecraft is currently headed into a 250-meter hold point. After that, teams will have pulled a go, no go. It will then reach a range of about 100 meters. And at 30 meters, we will have another hold point. Our first capture is scheduled for 5:55 a.m. Eastern Time, 4:55 a.m. Central Time. NASA astronauts Woody Hoburg and Frank Rubio will be using that robotic arm on the space station to capture the vehicle. After that, they will maneuver it to the installation site. At that point, they will pass it over to our robotics operator in Mission Control. They will methodically align it and push it into that common berthing mechanism. Then will come a series of latches and bolts to attach the spacecraft to the space station. After we have a successful berthing, the crew will conduct leak checks on board before opening that hatch door and starting to unload the cargo. A call out from Mission Control team members that everything looks good as the vehicle is approaching its 250-meter hold point. Cygnus is currently navigating with LiDAR. LiDAR is light detection and ranging. These are laser sensors that ping off of different reflectors on board the station. It gives it high fidelity data on its distance, rate of closure, and where it needs to line up to help guide its final approach. Cygnus will be installed on the Earth-facing port of the Unity module, also known as Node 1. This was the first U.S.-built component of the International Space Station. It connects the Russian and United States segments of the station and is where all of the crew eats their meals together. The Unity module was carried into orbit in 1998 on the first space shuttle mission dedicated to the assembly of the station. That was on STS-88, carried on Space Shuttle Endeavour. It is a tradition for Northrop Grumman to name their Cygnus spacecraft after a pioneer in space exploration who is deceased. They are proud to name the NG-19 Cygnus spacecraft in remembrance and celebration of the life of NASA astronaut Dr. Laurel Clark. She was an accomplished undersea medical officer and naval flight surgeon prior to her NASA career. During her first and only spaceflight, the STS-107, Dr. Clark and the rest of the crew aboard the Space Shuttle Columbia tragically lost their lives when the shuttle did not survive re-entry into Earth's atmosphere. This Cygnus spacecraft flight comes almost 10 years after the original Cygnus demonstration flight. That was SS David Lowe on September 18th of 2013. The two wings you see coming out from the side of Cygnus are its solar arrays. They are circular in nature and provide electrical power for the vehicle. We got confirmation that both of those solar arrays have deployed successfully and are successfully drawing power for the vehicle. Attached to that is the pressurized cargo module, as well as a service module. The service module provides the power, propulsion, and navigation, while the pressurized cargo module is where all of our cargo is inside.
Station Houston on Space to Ground 2 for Cygnus.
Yeah, 2 for Cygnus.
Confirm Cygnus 250-meter hold per step 2 in 1.102.
Copy. We see visiting vehicle mode hold. We do have a gray corridor displayed. We have matching LED status as expected. Good frame counter incrementation. And primary range is 252. And Megan, let me know when you're ready for a Block Bravo report.
Copy all. Ready for Block Bravo.
Okay, Block Bravo, the light is within the corridor. The vehicle is approximately 25% larger than the outline. The light is half a vehicle starboard of the circle, and the circle is half a vehicle port of centerline. And we see that per monitor 3.
Copy all. Thank you so much.
Capcom Megan Harvey speaking with NASA astronaut Frank Rubio, who is currently on board the International Space Station, working through those procedures to prepare and make sure that everyone is ready for the spacecraft's arrival. Everything is looking good so far. When we are just about 1 hour out from that initial capture window. NASA astronaut Woody Hoburg will be prime for that capture, with Frank Rubio assisting him. We are heading into orbital nighttime, but a great final view of the Cygnus spacecraft with those 2 solar arrays fully deployed. Cygnus is currently at the cusp of that keep-out sphere. You can see a graphic here that demonstrates both the keep-out sphere and the approach ellipsoid. That keep-out sphere is extremely close to the station. It is monitored by flight controllers. It's used to govern vehicles approaching and leaving the station. It allows for 4 orbits of safety if the vehicle were to lose control. Very unlikely event. Everything looks good so far today. NASA Mission Control team members are in joint operations with Northrop Grumman's flight control team. They are located in Dulles, Virginia. This is a view of that Northrop Grumman Mission Control in Dulles, Virginia. Cygnus was developed by Northrop Grumman and is part of NASA's Commercial Resupply Services program for the International Space Station. It is flying autonomously with commands being sent to it. There is no crew currently on board the spacecraft. Flight control teams in Houston are now polling for that go, no go for the vehicle to cross that keep out sphere.
Station Houston on 2 for Cygnus.
Yeah, 2 for Cygnus.
Cygnus and ISS are configured for approach inside the keep out sphere. Expect approach to resume shortly, and stand by for the Cygnus PCS command checkout.
Copy all, and we are ready for step 3.
Copy.
Capsule communicator Megan Harvey speaking with the crew on board. They are ready for Cygnus's approach. That capture is still on schedule for less than an hour from now at 5:55 a.m. Eastern Time, 4:55 a.m. Central Time. We do have an initial capture window as well as some different backup attempts if necessary. Cygnus is now proceeding to a 30-meter hold point.
2, Cygnus has resumed approach. Go for Cygnus PCS command checkout. Hold arm per step 3 in 1.102.
And we copy, go for step 3. And we see visiting vehicle mode as approach with primary range decreasing.
Copy approach, range decreasing.
Range for the Cygnus spacecraft is decreasing. That means it is getting closer to the station. When it reaches 30 meters from the station, it is going to enter another hold point. Teams will do a go, no go for it at that point for that capture attempt.
Houston Station on 2 for step 3. Hold command is armed.
Copy. Hold arm confirmed. Go for Cygnus PCS command checkout. Disarm per step 4 in 1.102.
Copy, go for step 4.
NASA astronauts Woody Hoburg and Frank Rubio are performing a series of checkouts to prepare to use that robotic arm. It is currently braked on board the space station. It's not moving, but they will be using it to capture the vehicle here shortly.
Houston Station on 2 for step 4. Hold command is disarmed.
Copy. Cygnus PCS command checkout was successful. Begin monitoring approach from 250 meters per step 5 in 1.102.
Copy, monitoring per step 5.
NASA astronaut Woody Hoberg is prime for Cygnus's capture today. He was launched to space on March 2nd, 2023 as part of the Crew 6 mission. Next to him is NASA astronaut Frank Rubio. He just celebrated his 300th day in space on July 18th. He is one of only 4 American astronauts to surpass 300 days in space on a single mission. Those other astronauts are Scott Kelly,
Station Houston on 2. Cygnus is inside the 200-meter keep-out sphere. Crew now has authority to issue an abort if no comm with MCCH, and the light is outside the corridor.
Copy all, Megan, and let me know if you are ready for a Block Bravo report.
Yeah, we're ready.
Okay, we see the light within the corridor. Unfortunately, current lighting conditions do not allow us to assess vehicle size or light offset from the circle, but the circle is half a vehicle starboard from corridor center.
Copy all. Thanks.
As you heard from Capcom, the crew on board does have the authority and ability to issue an abort for the spacecraft in case something goes wrong. However, things are looking good for Cygnus, and the team has full communication with the vehicle. You heard NASA astronaut Woody Hoberg commenting on the darkness, that he could not assess the size of the vehicle. As you can see here, that is because we are in our orbital nighttime. We are expected to be back in daytime in about 25 minutes. Our capture of the vehicle with that robotic arm is scheduled to take place. It's on track for 5:55 a.m. Eastern Time, 4:55 a.m. Central Time. After that, the crew will hand operations over to our robotic operator here in Mission Control Houston to berth it to the station. The crew will then perform leak checks on that common berthing mechanism before opening the hatch. That hatch open is scheduled for 1 p.m. Eastern Time today, or noon Central. Flight Director Fiona Turret, there closest on your screen, is the flight director today. As in the Apollo era, the flight director has utmost authority. She is leading the flight control team today and is responsible for the real-time crew safety, vehicle safety, and mission success of today's cargo resupply mission. Behind her is the CAPCOM position, that stands for Capsule Communicator. She is the voice link between the crew and the flight control team. That is Megan Harvey today. Behind the scenes is Visiting Vehicle Officer Nick Lopez. He is communicating between Northrop Grumman and the flight control team, reporting on Cygnus's performance and milestones. Our integration systems engineer is Lisa Milam. She is responsible for monitoring the key systems and operations of the Cygnus spacecraft as it approaches and mates to the International Space Station. Cygnus launched on Tuesday at 8:31 p.m. Eastern Time, 7:31 p.m. Central Time from NASA's Wallops Flight Facility on the eastern shore of Virginia. It's been over a 2-day journey for Cygnus to reach the International Space Station by the time it is captured and berthed to the station. Berthing is the term for the joining of two spacecraft vehicles. It is different from docking when we're talking about dynamic spaceflight operations. When vehicles dock to the International Space Station, it's on a different interface. For the common berthing mechanism that we're using today, it is larger than the typical docking interface, and it is similar to how the International Space Station was originally mated together. NASA's Robotics Operations Systems Officer today will be Jason Seagram. He's going to take control of the arm to conduct that final berthing to the station. He will drive a series of hooks and latches and bolts to secure it to the station. Cygnus will be berthed to the nadir port, that's the Earth-facing port of the Unity module. The robotic arm being used today is named the Canadarm2, or the SSRMS. That stands for the Space Station Remote Manipulator System. It's part of the Canadian Space Agency's contribution to the International Space Station. It's about 57.7 feet long when it's fully extended, and it was used extensively in the assembly of the space station. It lends literally a helping hand to perform station maintenance, move supplies, equipment, and as you see today, perform those cosmic catches by grappling those visiting vehicles and berthing them to the International Space Station. You are looking at NASA astronaut Woody Hoburg's view. This is his interface for monitoring the operations. Although we are currently in an orbital nighttime, the astronauts on board have all of the data available to them. In the bottom right of your screen, you'll see VV to ISS. That's Visiting Vehicle to the International Space Station. It provides the meters, that's the distance the spacecraft is from the station, as well as the range rate. Since the vehicle is getting closer, that range rate is decreasing. The vehicle will slow down where it will reach that 30-meter hold point. Teams will conduct a go, no-go for capture of the vehicle. Over 8,200 pounds of cargo are being delivered to the crew living and working aboard the International Space Station. Part of that, some very important research. Neuronics is sponsored by the International Space Station National Lab. It demonstrates the formation of 3D neuron cell cultures in microgravity and tests a neuron-specific gene therapy. Gene therapy shows promise as a potential treatment for people with paralysis and neurological diseases such as Alzheimer's and Parkinson's. However, the 3D models needed to test those therapies cannot be grown in Earth's gravity. Creating those cultures in microgravity could provide a platform for drug discovery and gene therapy testing. The team on board will also be welcoming a new system, the Exploration Potable Water Dispenser. It uses advanced water sanitation and microbial growth reduction methods and dispenses hot water. This device will significantly increase water capabilities for the crew on board. They can use it for food rehydration as well as supporting other experiments with potable water needs. NASA astronauts Woody Hoberg and Frank Rubio will capture the Cygnus spacecraft today. They are a part of the Expedition 69 crew that is currently living and working aboard the International Space Station. From the left, we have NASA astronaut Frank Rubio, Roscosmos cosmonaut Dmitry Patelin, Emirati Space Agency astronaut Sultan Al-Nayati, NASA astronauts Woody Hoberg and Steve Bowen, and Roscosmos cosmonauts Andrei Fedyaev and Sergei Prokopyev. Cygnus just passed that 50-meter mark. It is closing in on the space station. In the bottom right of your screen, you can see the meters. It is right at that 47, and that range rate is slowing, signifying that the vehicle is slowing down. It is going to hold at that 30-meter point. Grappling is the term for when a robotic element securely grabs onto something. That is what NASA astronaut Woody Hoberg is going to be doing, using the space station's robotic arm and grappling on the Cygnus spacecraft. There is an end effector camera at the end of the robotic arm, so we will be able to get live views. Another call out you will be hearing today is for the DSATs to be inhibited. These are the fuel thrusters for the International Space Station. They can fire if the station moves out of its planned location, and we don't want any movement as Woody is controlling that robotic arm. Once Woody aligns the robotic arm to the grapple target on the Cygnus spacecraft, we will be listening for a call out on those snares closing. The snares can be compared to the hand of the robotic arm. For now, we're looking out for that 30-meter hold and a go-no-go from teams in Northrop Grumman's flight control room in Dulles, Virginia, as well as a go from the flight control team at Mission Control here in Houston. Less than 30 minutes away from our estimated capture at 5:55 a.m. Eastern Time, 4:55 a.m. Central Time. It is preferred for Cygnus to be captured during an orbital daytime. However, there are lights on the robotic arm, so it can be captured during the night if needed. However, during this first capture window, we are going to be in an orbital daytime.
Station Houston on Space to Ground 2 for Cygnus.
For Cygnus.
Confirm 30-meter hold and set up for capture per step 6 in 1.102.
Okay, we see vehicle mode as hold, primary range as 30. And we are going to leave the light on and go into step 3 in 1.110.
Copy all.
The International Space Station is currently flying over the southernmost tip of South America, crossing over Chile, and then briefly into Argentina. Astronauts on board the station are going through their preparation steps. We are currently at that 30-meter hold position. We are less than 30 minutes away from our estimated capture time. Teams here in Mission Control are going through contingency plans. However, everything so far during Cygnus's flight has been performing as expected. Northrop Grumman's flight control team currently conducting their go, no-go poll for that final approach and capture. Here you can see the station's robotic arm. That is what is going to be used very shortly to grab the Cygnus spacecraft. Previously, you saw a view that was from the end of the robotic arm. At the end of that arm is the LEE, that stands for the latching end effector. It's the hand of the arm, and inside are those latches and snares that will grab on to the grapple target that is on the Cygnus spacecraft.
Houston, station on 2 for Cygnus.
With you on 2.
And Megan, the crew is ready for Cygnus approach to capture point.
Copy. Thank you.
Flight control teams at Northrop Grumman's facility in Dulles, Virginia, and mission control teams here in Houston have pulled go, and you just heard the crew aboard the International Space Station also pulling go.
Station Houston on 2. Cygnus is ready to proceed to the capture point. Expect approach to resume shortly.
Station copies.
Onboard NASA astronaut Woody Hoburg is prime for the capture of the Cygnus spacecraft. The vehicle will move through this 30-meter hold and move to a 10-meter capture point. At that point, you may hear that those DSATs are inhibited. That is to prevent any automatic thrusters from firing for the space station.
Station Houston on 2. Cygnus has resumed approach to the capture point. Monitor approach within 30 meters per step 7 in 1.102.
Okay, Megan, and we copy. We see vehicle mode as approach, current range at 28. Let me know if you're ready for Block Bravo.
We're ready.
Okay, and we have matching data on both monitors 1 and 3. We see that the light is within the corridor, the vehicle size matches the outline, the light is centered, and the circle is centered.
Copy all.
After NASA astronaut Woody Hoburg uses the robotic arm to capture the Cygnus cargo spacecraft, he will maneuver it to the nadir, or the Earth-facing port of the Unity module, to that common berthing mechanism. He will then hand it off to our robotics operator here in Mission Control Houston to install it to the space station. Cygnus moving very slowly towards that capture point, about 0.03 meters per second. We are closing in at 20 meters from the space station. At that 10-meter capture point, there will be another hold. More steps need to be completed. There will be another go, no-go poll. Those DSATs need to be inhibited to prevent the space station from moving. We are expected to get live views from a camera on the end of the robotic arm as it approaches the grapple target on the Cygnus spacecraft. We are less than 15 minutes from that first capture window. A brief look ahead after the capture of the spacecraft. It will be maneuvered to that Earth-facing port on Node 1, the Unity module of the International Space Station. After it is installed, our crew on board will perform leak checks, and the hatch is expected to be opened at 1 p.m. Eastern Time today, noon Central. And the crew will start unloading the cargo from the spacecraft. Cygnus coming into view on that camera at the end of the Canadarm2, also known as the SSRMS, or the Space Station Remote Manipulator System. Cygnus is less than 15 meters away from the space station and entering that 10-meter capture point. We will then wait for a go, no-go from teams. As Cygnus comes into view, you can see the grapple fixture there. You have a pinwheel-looking feature at the bottom, and then there is a horizontal bar just above that. Woody Hoberg, NASA astronaut who is prime for this capture, is aiming for that line and using it as a guide. The fixtures on the robotic arm will engage with that pinwheel shape directly below that horizontal bar. Cygnus has now reached its capture point, and it is holding.
Station Houston on Space to Ground 2, confirm capture point hold for step 8 in 1.102.
And Megan, we see capture point hold with a range of 12 and a rate of 0.
Copy.
And Megan, we have capture conditions met and confirmed, and the crew is ready for Cygnus capture.
Copy. Stand by for capture.
Teams are currently conducting their final polls for that capture. As you heard, NASA astronaut Frank Rubio let mission control teams here in Houston know that they are ready to perform the capture of the Cygnus spacecraft.
Station Houston on Space to Ground 2, go for Cygnus capture sequence. Step 4 in 1.110, Cygnus capture. Begin monitoring the back-away cue card.
Okay, capture. Okay, we copy. Go for step 4 in the Cygnus capture procedure 1.110, and we'll be monitoring the back-away cue card.
The robotic arm is not in motion yet, but it will be momentarily. NASA astronaut Woody Hoburg is at the helm for this capture. This is a live view from inside the International Space Station. This is the interface for monitoring the operations today. Confirmation that the robotic arm is in motion. NASA astronaut Woody Hoburg is moving it to the grappling mechanism on the Cygnus spacecraft. A live view from the end of the robotic arm as NASA astronaut Woody Hoburg guides it into the grapple target. Again, he is using that horizontal line as a guide. These snares are going to close around that pinwheel fixture just below that horizontal guide bar. Two meters away. One meter. Over the pin. The Cygnus spacecraft supporting Northrop Grumman's 19th commercial resupply service mission successfully captured at the hands of NASA astronaut Woody Hoburg at 5:52 a.m. Eastern Time, 4:52 a.m. Central Time as the space station flew over Mali in West Africa, 260 statute miles above the Earth. NASA astronauts Woody Hoberg and Frank Rubio, who were on tap to perform the capture of the Cygnus spacecraft, are relieved from their duties. They will go on to their tasks for the day. They will pass operations over to our robotics operator here in Mission Control Houston to finalize the berthing of the vehicle.
Houston Station on 2, Cygnus capture is complete. You have a go for Cygnus post-capture reconfiguration.
Copy, Frank. Beautiful job.
Hey, Megan. Thank you so much. Great job by Woody. That was picture perfect. And we'd like to say on behalf of Expedition 69 to the NASA team and the Northrop Grumman team, congratulations on the successful capture of the SS Laurel Clark. As we remember Laurel and the entire crew of the Space Shuttle Columbia, we remember that many great sacrifices have been made to get us to this point in human space exploration, and it's an honor to continue to push the needle forward in their memory. Great job, and we also want to say congratulations on the final flight of the Antares 200 series launch vehicle and the arrival to the International Space Station. Welcome.
Thank you so much. Those are great words.
Northrop Grumman's 19th commercial resupply service mission successfully captured by the station's robotic arm. NASA astronauts Woody Hoberg and Frank Rubio working together with flight control teams here at Mission Control Houston and in tandem with Northrop Grumman's flight control team in Dulles, Virginia. The spacecraft was captured at 5:52 a.m. Eastern Time, 4:52 a.m. Central Time. We will be taking a break and we'll be back on air at 7:30 a.m. Eastern Time, 6:30 a.m. Central Time for the berthing and installation of the vehicle, which will be done by the robotics team here in Mission Control Houston. If there is any adjustment to that time that we come back on air, we will notify you via social media. Thank you for joining us. This is Mission Control Houston.